DFS traversal. So DFS traversal is based upon something like called backtracking. You might have heard this concept many times. This is a maze problem. Let us suppose maze is here and there's some cheese is placed somewhat at this position. He wants to eat that cheese. Maze will start exploring from this direction. So maze will start from this side. Now what he will do in the memory somewhat, wherever he goes, he will just keep on say memorizing that chunk of the memorizing is, let us suppose he has two options to explore. So wherever he goes, say let us suppose spread some sort of marks are being there. So let us suppose he has got two options to explore. So he will mark this node that I have explored. He will go in this direction, and until unless it doesn't find a dead end. Once it finds dead end, that there is a wall inside this, so he will do the backtrack करके वापस आ जाएगा, return the steps backward when no unvisited options are there. So then it will come the backtrack will come to the gain to the safe state. Now he will start exploring the other way around, because he knows that this path has been now colored by him, by some traces have been spread on this path. Now he will start exploring this path. Now after exploring this path, he has got two options. Now he has spread some traces here. Now he has got two possibilities. So let us suppose he explore this possibility. Again he got a dead end. He will do backtracking from this, and now he has spread some traces like this. Now he will go to this direction, and so on. He will spread the traces and he will try to explore other options. This is the way maze tries to find its path. So same, this is nothing but DFS traversal. DFS, what it does, it tries, if there are two or three possibilities are there, the DFS tries to explore one possibility till it reaches the destination or the dead end. Because we are now relying on traversal, that means we have to explore every possibility. So in this case, this is just dead end, means this is a source and this is the destination. We need a path for that. We are not after the shortest path in maze problem. We are after only finding the path from source to destination. If our application is just find the path from source to destination, if there are, let us suppose, 10,000 nodes are there in a graph, and there is a source and there is a destination, and we through the exploration path we reach from source to destination, we will stop at destination only. Or in case we have to do traversal of all the nodes, then we will have to do backtracking and start exploring all the possible paths which are there for our purpose. That depends on the scenario. In this case, we'll be stopping from source until we reached at our destination. That means until we got the path. Here we are not dealing with shortest path that we did in BFS traversal. Here we are after only the path. Find the path if it exists between source and destination. If it doesn't exist, it will say your maze can't eat the cheese. So what will happen in this case? For DFS traversal purpose, we will have to do backtracking many times. So what is being done? The same concept is being used. It uses recursion. Recursively it tries to opt for the first path. Then it do backtracking. Recursion implicitly does backtracking internally. It goes deeper into the recursive side and then it come back to the calling function. So it repeats the same task. Go deeper, then backtrack. Again, explore the next path. Go deeper, then backtrack. Then go deeper, then backtrack, and so on. This way it explore all the paths. So it first go deepest to one side of that, like in this case maze problem, it goes one side deeper till it get the base path. Now no further recursion is possible, so it will go backtracking to the safe side. Here recursive call is possible, again it will do the same procedure. Mark each visited vertex, that means wherever you have visited those set of nodes, so those nodes are marked visited, otherwise it will lead to endless recursion. So while return when no unvisited options are being left. So retrace your path backward. So in this, it is nothing but backtracking is being done and recursion is being generally being opted for your DFS traversal. Now let us suppose these are the some application is there. These are some possible way outs if you want to explore all these possibilities using DFS traversal. If you are using BFS, so what sort of a possibility will be explored? For this is explored, then all these three possibilities are explored. Then this possibility, and for given this possibility is explored, and so on. It will go parallelly for every element one by one. So all the your traversals will be breadth-wise, they will be solved. But for DFS, first this possibility is explored, then it will try to go for this second step, this one. It will choose, it will go till deepest level, 4. Now here it has got dead end, it's a leaf node, it can't go move further. So what it will do, it will do backtracking to this side, then backtracking until it is able to get other option. Now second option is this one, this will go to fifth, then it will go to sixth, then it will go to the last seventh. Now at the dead end it will do backtracking back to the 7 to 6, 6 to 5, 5 to still one more is left to be explored, it will go to the seventh position here, then it will do backtracking from here, then from fifth, no, nothing is left, it is again dead end somewhat, everything has been explored, then it will go to backtracking, then it will go to the eighth, then it will go to the ninth, from ninth it will do backtracking, then 8 backtracking 1, nothing is left to be explored. Now this will come, will be the end of your DFS traversal. In this manner, it will go deeper to one side of the graph until all the things are being explored like this: 1, 2, 3, 4, then backtracking, then 5, 6, 7, 8, then backtracking, then 8, then backtracking, then ninth and 10th, and then backtracking back to the 1. So this is the way your DFS traversal works. So it goes deeper into the graph, undiscovered vertices remain, then DFS selects, okay, now one more thing which is to be added. Let us suppose I started from this source vertex, say this is the source vertex. This is a directed graph which has been shown for your purpose. I started from this vertex D, any vertex say, so I export this path, say this is the path, just wait, this is the path which I, uh, uh, just wait, let me give some another color. This is the path I explored. Like I went to this place, then from this place I go deeper first, then I explored this path. Then at this I got a dead end because there is nothing emanating edge from this. I have to do backtracking back to this. There is no other way to explore. I will do backtracking. I will come to this. There is a now. This is the other options are still left to be explored. This has been now explored. All the nodes have been explored. I will come to this side, this node is being explored, there is again dead end from this, again backtracking will done from this, it will come back to this original, this will also be explored. So just see in this graph, these nodes are never being explored in this. So what to do in this case? For we have to, because we are after traversal, so DFS traverse, if you are dealing with traversal tasks, that means we have to visit every node exactly once. These nodes, because of the structure of the graph, are never being explored. If you are starting from this as a source vertex, this is being explored, this is being printed, this is being printed, this is being printed, but these never because these are out of reach of this graph source vertex. If you see that directly, there is no way to enter into these nodes, you just see the directions of these two edges. So what to do, you have to start, this is source one, you have to take another any of the unvisited vertex which has not been visited by source 1 DFS traversal. You called DFS traversal on source 1 vertex, and still these vertices are not visited, it is still or white color unvisited vertices. You start from any of the unvisited vertices. Say if I start from this unvisited vertex, then I will call him DFS source of 2, that is second vertex. So this will be exploring this vertex also, your purpose will be solved. If your algorithm start from this vertex as a second vertex which is to be explored, like this DFS say source 3, this is source 3 vertex, still this will be left unexplored, you will have to again call DFS source 2. That means 3 times DFS traversal. Say first is this one, you tried for this, algorithm tried for this one, then algorithm picked this as a second vertex, then algorithm picked this as the third vertex. Accordingly, 3 times DFS traversal had to be done. If you are giving in this order, first this DFS traversal, then DFS traversal, this one, so no need to go for this because it will automatically explore this vertex because of the direction purpose. So if any of the undiscovered vertices remain after DFS, then DFS selects one of them as a new source vertex and repeats the search from that source vertex to do full traversal of your graph. Algorithm continues until all the vertices have been discovered. And depth first forest. Now in this case, if from the source vertex some trees, like just like DFS tree, depth first trees was being created. uh, Now this is not a single tree because of multiple source vertex. If there are multiple, like if I'm saying there are 3 source vertexes for my case, so 3 different trees will be created. DFS tree 1 depending for source vertex 1, DFS tree 2, DFS 3, tree 3. If there are 3 source vertices inside my DFS traversal, so this is a collection of tree. Collection of trees called forest. So this is called depth first forest, comprising of several depth first tree depending upon how many source vertices have been chosen by my algorithm. This works for both directed and undirected graph. Now let us just take three triplets of this. There will be one vertex which will be called, we are using for the sake of simplicity adjacency list for our case. We may also use adjacency matrix. If order of v plus c is a complexity in this case, order of running time, it is order of v square if you are using adjacency matrix. So color here is white, which is undiscovered color. Gray means discovered, means it has been, this node is now being a part of recursion. Once everything has been traversed, examined completely, that node is being made as black, just like we did in your BFS traversal. Similarly, that of BFS, there is a DFS predecessor. And now, other than earlier, there was just a simple uh, shortest distance path was there, this distance. Here there are two variants. What are those two variants? First time that vertex was being attentioned, and if all the vertices of that vertex has been examined, that means once that vertex get a black color, everything related to that has been processed. You set the finish time of that. You can say make it as a finish time. Some books do say it's a finish time, that timestamp. And there is a starting time when first time that vertex has become gray color. So these two tidbits, two times are being kept in DFS traversal. Now I will start directly with an example first of all, then I will switch to the algorithm part. If you see, just wait, if you see this example, there is a predecessor graph, and or you can say depth first forest inside this, because multiple trees can be made. That is why we are using the term depth first forest. Let us suppose this is a starting vertex which will be given to you. If it is not given, you can randomly select the same for your purpose in the exams. So this is starting vertex. So we are keeping the distance of there is a distance d oblique f. D is the time when your um, node was first being explored, or I will say it was of gray color. First time it has been called up for the recursion. Second thing is when the everything related to that have been explored, that means then when it becomes of black color, that timestamp. You assume timestamp is just like a timer which will, it's a clock tick which keep on incrementing every time. In every clock tick different operations are being executed. This is the runtime stack operation. It is not a user defined. You can take the help of user defined stack also for your purpose. So we are here this example we are dealing with the recursion. So we are using a recursive call. Basically, it is a recursive stack. So one time has been assigned, one unit time. Initially time is assigned as zero value. First time this node is being explored as a DFS of u. In that case, so increment your time is equal to time plus one, that, and assign the u dot d time, that is the starting vertex time, is equal to time. That means initially time was equal to zero, now time is equal to time plus one. So u dot time is equal to this, and u dot color is equal to gray color. Settle down these tidbits one by one. So if I see this, if you want to see this, first of all, let me tell you about something related to the coding part. Uh, 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 no, I won't be able to see the coding part here. I don't know where I've kept it. Let me see. Cancel. Okay, let us just first switch to this color is of gray color. After this, once you assign this as this gray color, this u has been added to the stack. After that, what you have to do next, find the adjacent to of this u. For every adjacent to this, you will call this DFS of this. Now once you added these tidbits into the graph, for every adjacent v adjacent to that of u, what you have to do, you have to call DFS of v. You have to call DFS of v. So recursively, this for this u, first adjacent of u is say t. So for this t, recursive call of DFS will be called. So DFS of this recursive call will do what? It will do increment time is equal to time plus one. Time will become equal to 2 unit, and t dot d will become equal to 2 unit, and t dot color will also become equal to gray, like this. This is added to the runtime stack. That is a recursive call. This t recursive call will further do what? It will again call w or x depending on the requirement. The w has been say called. Again timer has been updated. Remember this thing, for when you started for every vertex v, for we were saying u dot time, you settle down at it as a one, sorry, u dot d time, that is the starting time, and you settle down the color of that as that was gray color. every vertex V adjacent to you, you were saying you were calling DFS of V. So we have right now shown only for T. We have to explore that of Y also. But once it comes out from this T DFS transversal, only then this Y will be called for that vertex which is not been explored. If this is being explored by T only, then for Y this will not be called. Remember this thing. So for W, this 3 unit is there and it has been grayed out. What is the adjacent of W? They are picking up, say S. S has been picked. You can pick in any order. You can go for X also. That depends on your choice. So 4 timer has been incremented. S dot D has been taken as 4. It has been added to recursive stack. This is a recursive stack. Nothing has been popped out yet. So from for this we have called this R. R this as timestamp unit of 5 unit. That is the discovery time. Increment the unit by one step. From R we have to now from R the only thing which is left to be explored is V. We the R will be further being taken as this V will be explored. So we will have discovery time of 6 unit. Now after V, if you say DFS of V, find the your coding will say for find the all the vertices adjacent to V if you want to go deeper into that for this vertex V. Now there is nothing is left for no DFS transversal will be called for this vertex. So just like you are saying, this is a base case. No DFS transversal is being called. What we have to do? Come out from this because all the entries have been explored. Remove this recursive stack. No recursion is being further performed ahead of this V. Remove it and settle down it as black. Before finishing this, settle down the time of this also as by incrementing the timering of that. The timer will become equal to 7 and this will be blackened out. Basically, this is blackened out. You have not specified in the diagram. This is blackened out. So similarly, R for nothing is left for R. This timer interrupt has been settled down. Finish time, which is called all everything has been exported for R. This will also blackened out. And then coming back to the S, because in the same fashion, recursion will go from inner to outer. Now it is going to backtracking itself. S and nothing is left to be explored. No white node adjacent to this is left. So this will also being finished time will be assigned as 9 unit and this will also blacken out. All these have been blackened out now. Then W will come. W still has got something to be explored. So this will not be blackened out. This will neither will be blackened out. No finish time will be assigned. So it has still got one more node to be explored. So this will do 10 unit of time for the discovery time for the X node. So X node has got 10 unit of discovery time. So X, it has still nodes to be explored further for X purpose. If you recursively call this X, it has still got Y to be called for DFS transversal. So 11 will be chosen here as a discovery time for the node. Now, once you are exploring Y has nothing to be left explored. All the nodes have been grayed out or blackened out. We can see now this is a blackout node. This is a blackout node. If you see from coding, but this is blackout node. This rest of the nodes are gray nodes, gray out nodes. So for this Y node, what you have to do? You have to do now backtracking because we are left with no option. This is just a base call. Nothing is adjacent to. Now this has to be blackened out with the timer interrupt of 12 unit. So this will blacken out. This is also blackened out. This is also blackened out. Coming back to the previous state of this, the X will be blackened out accordingly with the time unit of 13 units, finish time you can say. And similarly, W will be blackened out in the same sequence in the form of recursive call with the unit of 14. Then T will be blackened out in the same method, and then U will be coming out with the same. Now this is the depth first tree which has been made depending upon the recursive call you applied for the same. Now remember this thing, how we have to prove the traversal. Just print all the nodes in the increasing order based on the D timestamp. D stamp means when the nodes were discovered, the first factor of the time. So first U, then second value is 2, that is T, then the smallest value remaining is 3, that is W, next node is W, then comes S, 4 node, then comes 5, that is R, then comes 6, this is node V, then comes here after V, next value is least value which is remaining is 10, that is X, then last is Y. So depending upon the print all the nodes in the form of increasing order based upon the this discovery time. There is a one other time, that is a finish time. We are not after this, we are only after the increasing order of discovery time for the traversal of DFS. This is another graph representation. This is directed one, and previous was undirected one. Just go, I will just try to figure out as early as possible for the vertex V. This is, that is the source vertex from where we are about to start. The DFS traversal, this will, let us first it's chosen B, then it has chosen say D. After D, it can choose alphabetically say the vertex. We are choosing alphabetically say A to B, then B to D, then D to C, then C to doesn't have any other option because this has been already being explored. Only one was there adjacent to, so it will do backtracking from this with the timestamp of 5 units for the finish time, and it will come back to D. For D, it has still got left some two tidbits to be explored. Let it be exploring first E. So for E, let it value is 6. It will be given in exams. Try to explore the nodes in alphabetical order in the increasing manner. So you will have to follow that practice only. Otherwise, it will be difficult for us to check the sheets. So 6 is being explored, then accordingly 6, then 6 has got dead end now. So nothing is left to be because it is has got only 3 in degree, no out degree. So 7 is a finish time for this. From this, it will do backtracking back to the calling function, that is D. So from D, it further explore because it has come from D only. So it will do the backtracking. It will come to this. Still one node is left to be explored. So this will go for 8 oblique F for 8 oblique. Then from 8, nothing is left to be explored because E has already been explored and A has also been already explored, both the nodes. So it will again do backtracking with the finish time of 9 unit. So it will come back to D. So D has explored everything. So this will have finish time of 10 units. Now coming to B. B has already been explored. It has got 11 unit of time. Then it will go backtracking. It will go to A. But A has not explored its nodes yet. So it will go for 12 as a exploration time for G, and it will go for 13 for because the dead end for this G, it will come backtracking, and 14, and print these values based upon the D discovery time of all the nodes in the increasing order. First A1, then B2, then D, then C, then E. After 4, this is 6 values there, then F, then G. In this way, you print all the nodes and follow the predecessor graph. So this is a crude step. Depth first traversal. Label, if you are starting from that vertex, label that vertex as reached or whatsoever the gray color you want to mention. For every each unreached vertex, for every white vertex which is adjacent to V, adjacent from V, adjacent to V आएगा basically. Okay, adjacent from V, one and the same thing. It should be adjacent to V. So it should be adjacent to V. Then depth first search for U. Apply recursively. So this is the basically. If you see, I have already told you that if the such graph is there, if you are starting from DFS traversal from say 2, obviously these all this will be explored, this will be still remaining, then you will have to call for DFS traversal for any of the remaining nodes. So system will search for the remaining nodes, like it will let us first see if you are going from sequence wise, it will try to explore 6 is still white. So it will call DFS traversal 6, based upon DFS traversal for 6, these will be traversed. So still the system will move further, so it will try to find 7. So it will call again DFS traversal on 7. So 7 is only explored vertex, then it will try to find anything left. So it will go for DFS traversal of 10 if you are going one by one in the increasing order of values. So here 4 times DFS traversal will be encountered because there are 4 different connected components of a given. This is single graph. So this may happen for your case in the exam also. You may get such graph. So you will have to call this DFS traversal those many times so that we can be able to traverse every node exactly once. The example says that initialize every vertex of the graph which is to be used for traversal purpose as white, and predecessor of all being nil, and the time to discover and time to once it has been explored, both the timing starting or finish time both are equal to, it has to be now initialized one by one. Initially timer is being set as 0. We are starting with the vertex U. If we are starting with that vertex, settle that as a gray color and set the timer time plus 1, that is equal to 1 unit of time here in this example. Like we have initialized everything, then this is the DFS traversal we're doing later in the subsequent sequence of times. So you are updating the time, you are updating the starting time of that U vertex and settle that to gray color, and we have to now procure every adjacent vertices to that of U. So U adjacent vertices are that of V. So DFS of U will be now first calling the DFS of V because V is adjacent to U. So this is the DFS visit of V vertex. So it will call DFS of V. So adjacent of V now will become equal to that of U. So in this manner, it will be calling, this was a white color, the DFS of U is calling now DFS of V first of all. So it has to do the transversal for every adjacent vertices, but it will first go deeper into first DFS of U will first go to DFS of V. The predecessor of that will become equal to U. Now DFS of V will do what? It will again increment the timer. Now here the value will be V. Timer will, starting time, the D discovery time will become equal to 2, and color will become equal to gray, and that of its now its adjacent 2 will be explored. Adjacent of V now will be explored for further processing. What are those adjacent to? That are Y. So DFS of Y will be invoked after this, and predecessor of Y will become equal to that of V. So predecessor of now Y will become that of V. And now you will focus on this. Once you are focusing on this, once you are going for DFS transversal of Y, now this is the sequence we are now following. DFS of U is calling DFS of V. DFS of V has called DFS of Y. Now we are at DFS of Y. When you are using DFS of Y, timer interrupt again incremented by 1 step. This will become, the discovery time is 3 unit, and the time color is now gray for this session of time, this vertex. And find the adjacent 2 of Y now. What is the adjacent of 2 of Y? That is X. X is of white color. Yes, X is of white color. Now settle down the predecessor of X now as Y, because Y has been called up, X has been called up by Y operation. Now we have to again invoke now DFS of that X adjacent to vertex. So this will call DFX of X further. Now further, when you are calling DFS of X, timer will be incremented. Now this is DFX visit of X. Time will be incremented. This will become 4, and the color of this X will become equal to gray. And for each vertex adjacent to X. Now adjacent to vertices X is V. V has already become grayed out. No, nothing is left adjacent to this. For this, there won't be further recursive call. No recursive call will be done further for DFS of X. So the color of this for loop, nothing is being white for that vertex X, which is adjacent to the vertices X, because V is there, but V is already grayed out. So what to do in this case? Settle down the color of that X node, because nothing is left to be explored. Settle down the color of that as now black. And before going further, start increment the timer interrupt. Timer was at 4 unit. Now increment the timer. Timer is equal to time plus 1. It will become 5 unit. And finish time of that X will become equal to 5 unit. In this manner, we can do further. Now there will be backtracking implicitly, because this is the base case for which recursive call of X won't be executed. The system will go back to the DFS of Y. For DFS of Y, it will explore second immediate vertex, because for Y, it has explored X now. No further is being left. Now DFS of Y has also completed the execution. It will come at this position in the recursive call. Y dot color will also get settled to now black. And the timer will be incremented for Y also. Timer will be 5 plus 1, that will become equal to 6. And the DFS of F now will become, finish time will become equal to now 6 here. Similarly, again backtracking, once it has finished, the DFS of V will be invoked. Now DFS of V set key, I was wanted to just explore DFS of Y, which this V vertex has done. Now V2 has explored all the vertices. So it will come at this position, because it has come out from this loop for this DFS V recursive call. So V dot color will become equal to black. From gray, this will become black, and its timer will be incremented. Time will become 6 plus 1, that will be equal to 7. That will become the finish time of vertex, this V. Once you got V has also been traversed. So backtracking, DFS of U will be invoked. Now once you're going DFS of U, because we went till V, so DFS of X will be tried. Now for X is already being grayed, blacked out. X won't be invoked. It will call DFS of V is also being come to dead end. So this will also black out. तो ये blackout हो जाएगा. इसका जो finish time होगा 7 plus 1 8 unit हो जाएगा, and so on. So this is the time, by the traversal of this, only these nodes will be explored. These won't be touched at all. If you just see carefully from the U, there are all the nodes which are involved in this DFS traversal of U. These are the nodes which are reachable from U. But if you can see clearly from the graph, these two nodes are not reachable because if you see the edges, it is from this direction and this direction. They are never reachable. So these won't be a part of DFS traversal of you. Only these nodes will be involved in this. If you want to print these nodes, you will have your system will again scan for the remaining white nodes, and it will call DFS transversal on that respective node. If you are going for alphabetically searching, it will try to find DFS of U. कहते it is already blacked out. DFS of V, it is already blacked out. DFS of then V, U, V, W. W is not blacked out. It will again call DFS visit function for W starting from W. With W it will traverse Z also. So next time you that again that mechanism will be played out. This is a just shortcut view what we have done so far. So till this your output will be till this. After this all these will be blackened out. Your system will stop after this. So again you have to explicitly call, system will call for W node again DFS visit function. How it will be calling? That is why we are saying for each vertex U, if it is a y this is DFS visit function, this is the DFS of G main function which will be calling DFS of visit function. So this implicitly will call DFS visit function two times. One is for U node and DFS visit second time for W node. Implicitly it will be calling this main function. So this DFS of U will traverse all, serve all these nodes, and further still you are getting W node as white color node, so DFS of W will serve these two nodes. So this there will be two binary depth first trees for the same which will be created. That is why we are saying one rooted at U, one rooted at W. This is all about your. You can go through this set of example. If there is any doubt, you can ask us. Ask me for the same. Let's say there are two trees which have been created. One starting from U, another starting from W. Now the same way we did how to print the elements for DFS traversal, we have to sort all these elements based upon the increasing order of that of discovery time. So first U will be printed, that V will be printed, then Y will be printed, then X will be printed, then W, and at last Z. So this is the output of DFS traversal. If somebody do ask with the example in the exam, you are supposed to write the same as the same way it has been written here. Okay, this is the code which I have already discussed. If you got doubt, you can ask me right now. We have already scanned this code. So because this is the main code where this is initialization one, this is a code where you're calling DFS visit for the non-visited vertex. So this will be called two times in the previous example. It has been called for U, then it has been called for W vertex. So this is a code, basic code, which is being used for DFS traversal purpose. Okay, this is the recursive pulse. Initially U is called, then DFS of V is called, then DFS of Y is called, then DFS of for Y, the DFS of X is called. For X, when you are trying for X at this position, तो X का adjacent to बनता है V. V आपका white होना चाहिए. जब आपका यहाँ पर X आया, तो X के adjacent to any all the nodes adjacent to X, वो V nodes जिनका कलर white है, तो इसका जो X के adjacent to बनता है V. V का जो कलर है सब आपका ग्रे है, तो कोई भी नोड नहीं है, तो ये रिकर्सिव कॉल DFS X के लिए रिकर्सिव कॉल ये नहीं करेगा. तो रिकर्सिव कॉल करेगा नहीं, तो इसके X के सारे एक्सप्लोर हो चुके हैं, तो X डॉट कलर ये कर देगा ब्लैक और टाइमर को इंक्रीमेंट करके इसका फिनिश टाइम बना देगा. तो ये आपका X डॉट कलर हो गया आपका ब्लैक और टाइमर इंक्रीमेंट करके 4 से +1 5 बन गए. तो ये आपकी फिनिश हो चुकी है नोड. अब ये बैक ट्रैक करेगा क्योंकि डी इसका बेस कंडीशन हो गई, खत्म हो गया. ये बैक ट्रैक करके आएगा DFS ऑफ Y. तो Y के एडजेसेंट टू और कौन से रहते हैं, कहते हैं कोई नहीं रहता जी, X हम कर चुके हैं एक्सप्लोर. तो डी ये Y भी खत्म हो गया, तो Y का फिनिश टाइम क्या हो जाएगा, Y बन जाएगा ब्लैक कलर का. जब Y अपने इस सिंटेक्स से बाहर आएगा, Y बन जाएगा आपका ब्लैक कलर का, उसका टाइम अपडेट होगा. टाइमर इज ए कॉमन टाइम और U.F आपका इंक्रीमेंट कर जाएगा एज अ 6. यहाँ 6 आ जाएगा टाइमर इंटरप्ट से और Y बन गया आपका ब्लैक. फिर DFS ऑफ Y के बाद था DFS ऑफ V. अगर आप इसको देखो बैक ट्रैक करके यहाँ से खत्म हो गया. फिर DFS ऑफ V के लिए क्या होगा, DFS ऑफ V के लिए फिर से वो V का एडजेसेंट टू कहते Y था जी और था ही नहीं कोई, तो ये भी ब्लैक कलर का हो जाएगा. और इसका आपका क्लोजिंग टाइम इट विल बी 6 + 1 7. टाइम इज अ कॉमन वेरिएबल जो हर बार इंक्रीमेंट कर रहा है. So that how to take now time from coding point of view, you can say take static int time variable. ताकि मल्टीपल रिकर्सिव कॉल में उसकी पहली वैल्यू वो सेव रखे। इस तरीके से यू कैन मूव अहेड। यहाँ पर 7 आ गया, वी वर्टेक्स वी, वर्टेक्स वी के बाद आएगा वर्टेक्स यू के पास। यू बोलेगा वी तो मैं एक्सप्लोर कर चुका हूँ, एक्स की बारी है। कहते हैं एक्स तो ऑलरेडी ब्लैक है तो यहीं पे रुक जाएगा, तो आपका ये यू को भी ये ब्लैक कर देगा और इसका फिनिश टाइम क्या हो जाएगा 7 + 1 8 यूनिट ऑफ टाइम। तो इस तरह से वो अपना ये पूरा पाथ कंप्लीट कर लेगा। रिमेंबर दिस थिंग, डब्ल्यू और जेड अभी भी नील है, वाइट है। क्यों? क्योंकि ये वाली जो नोड्स हैं डीएफएस ट्रांवर्सल ने ये सारी ब्लैकआउट कर दी। ये यू से ये अप्रोचेबल है, डब्ल्यू और जी जो आपकी हैं ये यू से अप्रोचेबल नहीं है सोर्स वर्टेक्स से। इसके लिए आपको अलग से डीएफएस ट्रांवर्सल लगाना पड़ेगा स्टार्टिंग फ्रॉम डब्ल्यू और जी। अगर अल्फाबेटिकल ऑर्डर में कर रहे हैं तो आपको अलग से लगाना पड़ेगा। इसके लिए कोड तो आपको ये डीएफएस ऑफ विजिट ऑफ पर्टिकुलर नोड के लिए था, ये वाला जो कोड था ये हमारा मेन कोड है। तो डीएफएस जी करेगा सबसे पहले सारी नोड्स को वाइट कर लो, उसका प्रीडिसेसर निल कर लो, टाइम कर दो 0, दिस इज इनिशियलाइजेशन मैट्रिसेस टिल फोर्थ नोड। उसके बाद हर वर्टेक्स के ऊपर जो वाइट है उसके ऊपर डीएफएस विजिट लगाओगे। तो सबसे पहले डीएफएस विजिट लगेगा यू, तो यू वर्टेक्स के ऊपर अल्फाबेटिकली जाए, इस पे डीएफएस विजिट लगा। इसने चारों की चारों नोड्स को इसने ब्लैकआउट कर दिया एक विजिट लगने से। तो जब विजिट लगा तो इसने चारों नोड्स को प्रोसेस कर दिया, ट्रांवर्स कर दिया। अब फॉर ईच वर्टेक्स फिर ऊपर से फिर गया नेक्स्ट वर्टेक्स ऑफ ग्राफ, अगर वो व्हाइट कलर की है कहते यू के बाद वी है, नहीं जी ब्लैक कलर की है। वी के बाद क्या है अगर अल्फाबेटिकली करे कहते डब्ल्यू, डब्ल्यू इज अ व्हाइट कलर। फिर यहाँ पर दोबारा से फंक्शन लगेगा डीएफएस विजिट डब्ल्यू। अब सारी प्रोसेसिंग पूरा का पूरा सिंटेक्स डब्ल्यू से शुरू होगा अल्फाबेटिक। डब्ल्यू अपना इसका टाइम स्टैम्प क्या होगी जो प्रीवियस टाइम स्टैम्प थी +1। तो टाइम इंटरप्ट में टाइमर में 8 है तो डीएफएस का बन जाएगा यहाँ पे 9 और ये बन जाएगी ग्रे नोड। पूरा प्रोसीजर शुरू हो जाएगा उसके अकॉर्डिंग। ग्रे तो बन गई और ये आपका टाइम हो गया। इसके एडजेसेंट टू डब्ल्यू के कौन से कहते हैं वाई एंड जी। तो वाई आपका ऑलरेडी ब्लैकआउट हुआ है, इट इज नॉट अ वाइट नोड, पर जी इज अ वाइट नोड। तो ये क्या करेगा यहाँ पर इसको कर देगा इसका एक्सप्लोरेशन टाइम 10 यूनिट, इसको ग्रे आउट कर देगा। तो दैट मीन्स डीएफएस विजिट ऑफ W will further call DFS visit of Z and so on। अब Z के लिए आपका क्या हो जाएगा, Z के कॉरेस्पॉन्डिंग ये ऑलरेडी ये गलत लिखा हुआ है, Z का Z नहीं, हाँ सेल्फ लूप है। तो Z के कॉरेस्पॉन्डिंग Z खुद को ही है, खुद ये ऑलरेडी ग्रे आउट हो चुका है तो इसके एडजस्टेंट टू कोई भी वाइट नहीं बचते। तो ये क्या करेगा खुद को इसको बट इट विल डू, ये ब्लैकआउट हो जाएगा। ब्लैकआउट होके इसका कम फिनिश टाइम हो जाएगा 11 यूनिट, ये ब्लैकआउट हो जाएगा यहाँ पर। तो इन दिस सेंस आपका ये खत्म हो जाएगा। फिर ये रिकर्सिवली वापस W के ऊपर आएगा, W का ऑलरेडी Y और Z दोनों हो चुके हैं, ये भी ब्लैकआउट हो जाएगा और इसका फिनिश टाइम बन जाएगा 12 यूनिट। और दिस प्रोसीजर यू हैव टू अप्लाई इन टर्म्स ऑफ कोडिंग। तो आपको एक कोडिंग की फॉर्म में लगाना है। अब आप देखो क्या लगाना है, आपकी चॉइस है। तो आप स्ट्रक्चर के अंदर आप वेरिएबल वर्टेक्स को रिप्रेजेंट करने 4 वेरिएबल लिखने। 4 वेरिएबल आपका कलर, टाइम स्टैम्प दैट इज डी एफ एंड पाई, 4 वेरिएबल लेके आप कोड लिख सकते हो इसका। और टाइम एक आप स्टैटिक वेरिएबल ले लो ताकि आप विद इन मल्टीपल फंक्शन कॉल्स इसको स्टैटिक एंड लेना उसी फंक्शन के अंदर, ताकि मल्टीपल फंक्शन कॉल्स के अंदर टाइम की वैल्यू रिटेन हो। स्टैटिक इन टाइम करोगे वैसे ही वो इनिशियलाइज हो जाएगा 0 से। बाकी सारा रिकर्जन है ही जो आप कर रहे हो, इसमें नथिंग स्पेशल इनसाइड दिस। पाथ चाहिए u2x, any node from starting node till ending node I need to print the path. What is the path from starting till ending? Say start is your u to any of the destination node। ये मुझे गिवन है तो कैसे करोगे, ये ध्यान में रखना जिसका भी पाथ निकालना है तो वहां से ट्रांवर्सल करनी जरूरी है तभी आपको पाथ मिलेगा। u to end, now how to find रिकर्सिव कोड कैसे लिखोगे, जहां मैंने पहले बताया था एंड के का प्रीवियस निकालो। इफ एंड का आप निकालोगे प्रीडिसेसर पाई डॉट एंड या एंड डॉट पाई जो भी लिखना चाहते हो आप, प्रीडिसेसर आ गया। अब आप इस प्रीडिसेसर का आगे फिर से प्रीडिसेसर निकालोगे, रिकर्सिवली चलेगा ये। कब तक, जब तक उसका प्रीडिसेसर फर्दर जो स्टार्टिंग नोड है उसका प्रीडिसेसर क्या है नील, या तो आपका उसका प्रीडिसेसर यू ना बन जाए, जैसे इसका प्रीडिसेसर यू ना बन जाए। तो यू विल बी कॉलिंग द पाथ ऑफ u to, and you will be calling the function path from u to, आपका क्या हो जाएगा एंड ऑफ इसका आगे पाई। तो आप इसको आगे करते करते जब तक आपका ये जो एंड ऑफ पाई, जब आपका खुद यू ना बन जाए, तब तक आप उस पाथ को साथ साथ प्रिंट करवाते जाओ, जो जो इंटरमीडिएट नोड्स आ रही है, रिकर्सिव फैशन है। सी आउट आप यहाँ लगाओगे, अगर आपने सी आउट ऊपर लगा दिया तो वो उल्टी डायरेक्शन में प्रिंट करेगा, तो आपको सी आउट यहाँ लगाना पड़ेगा नोड्स के पाथ के लिए। ये आप खुद बना सकते हो कोड। BFS ट्रांसवर्सल वाज यूज्ड फॉर शॉर्टेस्ट पाथ, जो अभी बताया था। BFS जो था, ये थोड़ी सी क्वेरी वही है, फॉर शॉर्टेस्ट पाथ कैसे निकालना है। जैसे इसकी एग्जांपल ली थी, तो ये ट्री बनता है, BFS ट्री मैं बता चुकी हूँ आपको क्या था। तो ये ट्री बन जाता है जब आप ट्रांसवर्सल करते हो, क्यू में डाल के क्यूब से निकालना। तो एस के शॉर्टेस्ट पाथ वाले वन वन यूनिट के शॉर्टेस्ट पाथ एस के आर को डब्ल्यू है। अगर इसकी बात करें तो यहाँ से 1 यूनिट डिस्टेंस से V 2 यूनिट डिस्टेंस है, V X और T। V कहाँ है दिखता है, V X और T ये 2 यूनिट डिस्टेंस के सारे वैल्यूज हैं। U और Y ये 3 यूनिट डिस्टेंस है S से। तो ये इस ट्री से आपको कलर कितने यूनिट डिस्टेंस है, तो शॉर्टेस्ट डिस्टेंस निकालो सोर्स वर्टेक्स से सभी नोड का। तो डिस्टेंस इम्प्लिसिटली यहाँ से निकल रहा है, ये देखो, दिस इज द मैट्रिक्स व्हिच इज बीइंग यूज्ड विद लेवल वाइज, कौन कौन सी लेवल में कितनी कितनी डिस्टेंस है। स्टार्टिंग वर्टेक्स है एस। तो ये डिस्टेंस आपको पूछ रहे हैं इस क्वेश्चन में।